Hi everybody, Mr. Vidic here. Today we're going to do part two of our applications of systems of linear equations. Uh, we're going to specifically look at mixture problems and also distance, speed, and time problems, which you'll definitely encounter in physics next year. Okay, let's get right into it. So in example number one, we have cashew nuts and Brazil nuts, and cashew nuts cost $22 per kilogram, and Brazil nuts cost $16 a kilogram. The entire mixture weighs 50 kilograms and sells for 18 kilograms a bag. The question is how many kilograms of each type of nut were used in the mixture. So the first thing you want to do is label some variables here. Again, our goal is to come up with equations from these sentences, two equations. That's going to help us form the system so we can solve for the variables. So, cashew nuts, I'm just going to use the letter C. So I'm going to say let C equal cashew, or I should say the weight of cashews, okay, and then let B be the weight of Brazil nuts. So our first equation is relatively straightforward. We're just going to add those two weights, the cashew nuts plus the Brazil nuts, to get to get the entire mixture, which is 50 kilograms. Okay. The second equation is a little bit harder. In the second equation, we have to get the value of each of the nuts. So we have $22 per kilogram and $16 per kilogram. Now, how much did the entire bag cost? Well, if there's 50 kilograms of the entire mixture and the whole thing sells for $18 per kilogram, well, I'm just going to go ahead and go 50 times 18 to get the cost of the entire bag. Well, how much? Now you have to ask yourself, how much of the entire cost did the cashews contribute to, and how much did the Brazil nuts contribute to? Well, the cashews cost $22. So $22 per kilogram, and then how many kilograms? Well, again, the kilograms, and I should probably say this up here, I should say weight of cashews in kilograms, because they're both in kilograms. So I'm going to go $22 times C plus $16 times B. Okay, and now I basically have two equations, and we can go ahead and use our system of equations. So the easiest thing that we can probably do is just multiply the top by 22. So we'll get 22, and then 22 times 50 is going to be 1100. And now we can start subtracting things. So once I subtract this, I'll get rid of the cashew nuts, and I'll have 22 minus 16, which is 6b, equals, I should also get this 15 times 18. 50 times 18 is going to be 900. So the difference there is going to be 200, and then 200 divided by 6 is going to be 33.3 repeating. So again, that is, again, go back to our definition of B here, and that is the weight of Brazil nuts in kilograms. And if the whole thing was 50, and then 50 minus 33.33 is going to be 16.67. So the cashew nuts are 16.67 kilograms. Okay, let's do the chemistry one. The chemistry problems seem to be the toughest one. So let's go through this slowly, step by step here. So we have Earl the chemist has to make 180 milliliters of 60% hydrochloric acid solution. Okay, he has available 1 liter bottle of 45 hydrochloric acid solution and 1 liter bottle of 70% hydrochloric acid solution. So basically, we have different concentrations of HCl, and we want to make sure that we want to come out with 60% HCl from these two separate bottles. All right. It says how many liters of each solution are mixed to make the 60% hydrochloric acid solution. So again, the key thing that you have, again, you have the quantity and then the concentration are your two equations. Just like in the Brazil nuts here, we had, this was equation 1 was the quantity, and equation 2 was the value of the cashew nuts. And this one, we're again going to have the quantity of the acid and then the concentrations of the acid. So the first one is fairly straightforward. Again, we have two bottles, so we can call them bottle A and bottle B. So bottle A plus bottle B is going to equal 180 milliliters of the solution. Okay, so that's the quantity. The quantity is usually the easier equation to come up with. Now the concentration equation, so let me go ahead and label this one 1 and this one 2. The concentration equation is going to be a little bit harder. The key thing to keep in mind here is that if there's 60% HCl solution, that means that there's 40% of other things, usually water. Okay, so in these bottles, there's 45% HCl and then 55% water, and so on. Okay, so the final, this one, for equation 2, we just want the concentration of just the HCl. So how much of this 180 milliliters is just HCl? Well, if it's 0.6, if that's what we want to get to, 60% HCl, we know that 0.6 times 180 milliliters is going to be just the HCl. Okay, well, now we want to know how much of each of these bottles, in each of these bottles there is hydrochloric acid. So in bottle A, well, bottle A contains 45%, so it's going to be 0.45 times A. That's just the HCl from bottle A plus the HCl from bottle B, which is 70%, should equal all the acid in the final mixture. And all the acid in the final mixture is just 0.6, 60% of 180. So 0.6 times 180, and that's going to be that's going to be 108. So that's the final the final amount of acid HCl in the final solution. So there you go. So once we have this set up, we can go ahead and multiply. I'll multiply the top one by 0.7. I usually multiply by the bigger number so we don't get any negative numbers. So it's going to be 0.7, 0.7, and then 0.7 times 180. Let me do that on my calculator. 0.7 times 180 is 126. So 126, and then now we can go ahead and subtract here. So 0.7 minus 0.45 is going to be 0.25, 0.25A. The B's cancel, and I get 126 minus 108, which is 18. So then once again, I'm just going to solve for A now. A divided by 18 divided by 0.2, which is just the same thing as multiplying it by 4, is going to be 72. So and then B is going to be 180 minus 72. So 180 minus 72, 108. So here's so what do these represent? Well, these represent, of course, A and B represent the amount of each solution, water and HCl included in the bottles. So it says how many milliliters of each solution are mixed to make the HCl solution. So these are the original. So in bottle A, if we had our beaker, chemistry beaker in bottle A, we'd have 72 milliliters, and bottle B might be a little bit bigger, 108 milliliters. Okay, so these two solutions, when mixed together, we're going to come up with 180 milliliters of the final solution. Now, some of that, again, some of this 72, right? 45% of it is acid, and then 70% of the bottle B is acid, so a little bit more like this, and then the final bottle is 60% acid, so a little bit more than half So that's kind of how you want to look at it. So the green is the acid, but the red is the total amount of liquid. Okay. All right. I'm going to just do one of these problems here, distance time problems. And again, this is you're going to encounter these type of problems quite a bit in even in Science 10 and definitely Physics 11 if you go on to take that course. So these are definitely very useful problems. Okay, so this equation here, this little triangle, is kind of like a cheat sheet that says distance equals speed times time, or in other words, we can rearrange that to have speed equal distance over time, or we can have it time equal distance over speed. So this is just the same equation, and this is this little triangle that kind of helps you. So S equals D over T, T equals D over S, or D equals S times T. Okay, so let's go ahead and get through this example number 3. A student drove the 1,245 kilometers from Edmonton to Vancouver in 16 hours. Now I like to make diagrams here whenever I do distance speed time problems. So I'm going to go ahead and put Edmonton over here and Vancouver over here, and it says student drove from Edmonton to Vancouver, and the distance was, so I'll put D equals 1245 kilometers, and it took him 16 and a half hours, so we're going to just go time equals 16.5. Okay, this included a 1 hour stop in Golden and a 30-minute stop in Kamloops. Okay, so let's go ahead and you know, we can put this little stop time here. Stop time is equal to 1.5 hours, and then we get the information that says she averaged 100 kilometers an hour on the divided highways and 75 kilometers on the non-divided mountain roads. Okay, so how much time did she spend on the divided highways? Okay, so let's label on our diagram here. We can label, you know, 2 sections. One of the sections is the highways, and I'm not really sure, you know, how much she drove on the highways, but we can just label it over somewhere here and say that you know, this section was 100 kilometers an hour, and this other section here was let me go ahead and do a little like that, and this other section here was 75 kilometers per hour. Okay. This is how much time did she spend on the divided highways, which is this first little bit here where she drove a little bit faster. All right, so the first thing I want to do is I want to get the actual time of driving. So this is the total time, but I don't really care about the stop time because she wasn't really driving then. So the stop time, I'm just going to subtract that away from the entire time, and that's going to give me 15 hours of just driving. Okay, so now I want to know how much of that 15 hours did she spend on each of the highways. All right, so for the first, so I need to come up with, again, several equations here. And you want to split this up into 2 sections. I'm not sure what happened here. That's weird. Okay, 2 sections. Oh, that's weird. Let me try this. Okay, I'll just ignore that. 2 sections of driving, obviously the mountain highway and the divided highways. So let's start with the highway, the fast highway. So that's going to be, let's call that distance 1. Okay, we'll call that distance D1. D1 is going to equal, well, what does D equal? D equals speed times time. So, but the speed for the fast highway was 100 kilometers an hour times t, and we're going to call that T1 because it's because again that's the first bit of that she drove on. Okay, so that's the first equation there. And now we're going to come up with the second equation. The second equation is going to be D2. Okay, that's the second part. D2 equals 75 times T2. Okay. Now, unfortunately here, let me just go ahead and label these, 1 and 2 here. Unfortunately, we have, way too many unknowns now. We have D1, T1, D2, and T2. But there's a little trick you can do here just to eliminate some of these variables. For example, we know that, and I can do that off to the side here, we know that T1 plus T2 equals 15 hours. So therefore T2 equals 15 minus T1. Okay, now I can go ahead and substitute that into T2. So I can rewrite my equation as distance 2 equals 75 times 15 minus T1. And now I've gotten rid of one of my variables, and I still have D1 and D2. But luckily I also have I also know that, and again I'm going to do it off to the side here, I know that D1 plus D2, that's the two distances, the two highways, equal a total of, the total, and what was the total driving, total distance was 1245 kilometers. Okay, so I know that these two added together are going to give me 1245 kilometers. So I can just use that information and go ahead and add these two equations and make them equal 1245. So D1 plus D2 should equal 1245. Now instead of putting D1 and D2, I'm just going to go ahead and put these other things in for D1 and D2. I'm just going to substitute those in for D1. In other words, I'm going to put this in for D1 and this in for D2. So I'm going to get the final equation is going to look like this: 100 T1 plus 75 15 minus T1 equals 1245. And now finally, after all that substitution, I have to do it several times. I have one equation and only one unknown variable, and that's T1. And as a matter of fact, T1 is what I'm looking for, because T1, remember, T1 is the first part. This is going to be, again, right here, that's going to be T1, and this is going to be T2. And the question says, how much time did she spend on the divided highways? And that is T1. So once I solve for T1, I can now, I'll basically have my answer. So let me go ahead and do that. So here we go. First distribute, so 100 T1 plus 75 times 50, 1125 minus 75 T1 equals 1245. So 25 T1 equals 120, and then T1 equals 120 divided by 25, and I'm going to for that, and T1 equals 4.5 hours. All right, and that seems to make sense, as she drove, fairly quickly. She drove 100 kilometers an hour for 4.5 hours, and then she drove the rest of the way, which was about 10.5 hours on the slow driving. And if you do go to, if you ever driven to Edmonton, you will know that most of the trip is through the mountains, so that seems to make sense. Okay guys, thanks for watching, and see you in class.